Chapter 6, Section 4 is labeled graphing, but we're kind of doing two different things that indirectly deal with graphing. The first thing we're dealing with today is rewriting things in standard form. So right now we kind of see it in vertex form, which is what we were working with yesterday, and we want to get it into standard form, which is what we were working with a couple days ago. So the first thing we're going to notice is we've got 3x plus 1 squared. So we remember from our very first day that that squared means that there's really two of those, 3x plus 1, and that we should, you got it, FOIL, your favorite thing, and that you remember to leave this 2 to the end. So if I FOIL that part, I get 9x squared plus 3x plus 1, or 9x squared plus 6x plus 1. Some of you may have even used the shortcut there and still gotten to there. Either way, that's cool. We're going to multiply all of that by 2 now. So now I've got y plus 8 equals 18x squared plus 12x plus 2. Now to get into standard form, I need to have y by itself. So all I'm going to do is subtract my 8 from each side. So I've got y equals 18x squared plus 12x minus 6. So that was pretty simple. All I needed to FOIL, all it do is FOIL and then move over my 8 at the end. So now we're in standard form. So if we try example B, I'll do this way with the shortcut. Again, you're going to kind of leave your 1/2 till the end. It says take the first thing squared. So 4x squared is 16x squared minus 2 times the first thing times the last thing plus the last thing squared. So the shortcut gives me 16x squared minus 4 times 2 is 8 times 2 is 16x plus 4. Now I'll go ahead and multiply all of that by 1/2, which gets me 8x squared minus 8x plus 2. And that right now equals y minus 3. And to get y by itself, I would just add 3 to each side. So my final answer of this version in standard form is 8x squared minus 8x plus 5. Okay, so that should be pretty straightforward. But we're working today a lot in standard form, so we just kind of wanted to know how to go from one form to the next. The second part of today is kind of working with how to put the equation if we're talking about the height of an object. You may have seen this formula if you are in chemistry or physics. G stands for the gravity. Okay, H stands for the height of the object. T is standing for time. So T is always dealing with time. Usually we're talking in seconds here. V sub 0 stands for the initial velocity. So what is the velocity at the very beginning? And H sub 0 stands for the initial height. So if I was going to throw a ball, it would start at a height of 5'2", which is how tall I am, and then an initial velocity of probably not very much because I'm not super strong, but those are the ones you're going to be plugging in for. Okay, and gravity is one of two numbers. If we're dealing in feet, it is going to be 32 feet per second. If we're in meters, it's going to be 9.8 meters per second. These two numbers are going to be numbers you're going to want to commit to your memory. Okay, feet is 32 and meters is 9.8. And that's always going to go in for your G in that equation. So if we take a look at our first equation, the first one says, suppose a ball is thrown upward from a height of 5 feet with an initial velocity of 44 feet per second. And the first thing we want to do is write the equation. So we've got y equals, or h equals would probably be even better here. So we're saying h equals -1/2, and the formula says G. G stands for gravity, and we're talking in feet. So I'm going to take the 32, and then it says T squared. Okay, so T squared stays in it just like an X would. Then it says plus V sub 0, which is your initial velocity. And here our initial velocity is 44. So plus 44 T. Again, T always stays in your equation. Hopefully you can see the difference between your plus and your T. And then plus your H sub 0, which is your initial height of 5. Okay, and you do want to make sure that you simplify this. So your final answer should be -16 T squared plus 44 T plus 5, and I'll use capital T's now, hopefully to make it a little easier for you to read. Okay, so that would be your equation for part A. Part B says to actually graph it. Okay, well, to graph it, maybe it would be a good idea to make an XY chart. Okay, or maybe even better, a T and H chart. So time and height. Time will go on the x-axis, and height will go on the y. Okay, so let's find out where it would be after 0 seconds. Well, after 0 seconds, it would give me 5. Okay, if you use the equation and plug it in, you should get 1 second will give you 33, 2 will give you 29, and 3 will give you -7. So if I kind of go by 5s over here, and then 1s on the x-axis, I've got 0, 5, 1, 33, 2, 29, 3, -7 is already down here. So the path of my ball would be about that. Okay, so how high is the ball after 1.5 seconds? So don't guesstimate it, but go ahead and plug in 1.5 for t into your equation, and you should get 35 feet. Please make sure that you are labeling feet or meters. Okay, it's really important that you're labeling these. And example or question D says, use your graph to approximate when will the ball hit the ground. Well, we know at 3 feet, it's already hit the ground, so it's somewhere between 2 and 3. By my graph, it would look like, I don't know, about 2.7 seconds. But your graph might look a little different, so it would just need to make sure that whatever that point is what your answer matches up to it. Okay, so that's a guesstimation. We will exactly learn how to find that tomorrow or the day after. So look forward to that. Okay, so let's try example D. Suppose a toy rocket is launched so high that its height in meters after t seconds is given by that equation. So this time it's giving us the equation, we're kind of working backwards. How high is the rocket when it's launched? Well, when it's launched, that would be like the starting amount, which would be the initial height. So if you remember, this was the gravity here, this was the initial velocity here, and this was the initial height. So how high was it when it was launched? 1.5. Now I told you that you had to label it, and we are talking in meters here. And how high is it after 1.5 seconds? So all I would do is plug in 1.5 for t. So let that equal 1.5. Plug that into your calculator, and you should get about 20.5 meters. Okay, so hopefully you can also work backwards. If they had asked me my initial velocity, I would have said 20 meters per second. Okay, so working backwards as well. All right, let's try example E. This time John is on top of a 60-meter tall building and he throws a ball into the air at a velocity of 10 meters per second. Write the equation. Okay, so again, same equation. H equals -1/2 is just part of it. Then the G comes next. G in meters, gravity is 9.8, good job. And then t squared is in them, plus v sub 0, so your initial velocity, which they said is 10, t, plus my initial height. Well, 60-meter tall building will be my initial height, so plus 60. Okay, so again, you want to simplify that. -1/2 times 9.8 is -4.9. So t squared plus 10t plus 60. Do make sure that you simplify that. Okay, if you notice, if we always use 9.8 and it's always -1/2, if you're in meters, it's always going to be -4.9. If we were talking in feet, it would always be 32, and 1/2 of that would always be -16. So if you can remember that, you can go straight to that if you would like. And then question B says, how high is it after 2 seconds? So all you have to do is let t equal 2, plug that in, and you would get about 80.4 meters. If you're not getting these same numbers on your calculator, really make sure you're watching the negatives and how you're squaring it. Okay, so let's try example F, last one. Suppose that Mary is doing a science experiment and has to drop an egg off the roof of her school. The egg weighs 3 ounces and the school is 50 feet tall. Write the equation. Okay, so I've got H equals -1/2. G is gravity. We're dealing with feet here. So if you look to your table, that's 32. T squared plus my initial velocity. Does it say initial velocity? Not that I can find of, but I did say I'm just dropping it. Velocity means how fast it's throwing it. So if you drop something, you don't have any velocity. So plus 0t plus your initial height, which is 50. Okay, so read carefully. We didn't care that the egg only weighed 3 ounces. Okay, in this equation, we do not care. So I'll simplify. -1/2 of 32 is -16. T squared, I don't need that 0t, so plus 50. Now that I have my equation, I can answer the question, how high is it after 2 seconds? Again, just plug in 2 for t, and you should get about -14. Well, if we're talking about -14 feet is the height of the egg, Where is the egg? Probably splattered on the concrete somewhere. So you should really just say on the ground. Now, some of you might say, oh, well, maybe it's in a pool and it's 14 feet in the pool. Okay, well, you're not going to assume that. So if you ever get a negative, you're just going to tell me that the ball is on the ground. Okay. All right. So that's the end of today. So stop, think. What do you still have questions about? Okay. Write those down and we will talk about those